In the last lecture, we have seen what is a solar photovoltaic cell and what is its voltage when it is open circuited, when sunlight is falling on it. So today we will see, or in this lecture we will see, what are the different types of photovoltaic cells and how its efficiency is going to vary with respect to the cell type, right? So there are three basic types of solar cell. They are monocrystalline, polycrystalline, as well as amorphous or thin film solar cell. So you can see those three types in these figures. The left one is monocrystalline and the middle one is polycrystalline, as well as the side one, that is right one, is mounted solar panel one, right? So the amorphous or thin film is not given here. They just given mounted solar panel here, but the left one you can see the monocrystalline type and the middle one is polycrystalline type. Okay, so what is this monocrystalline silicon and what are its characteristics? So monocrystalline or single crystal solar PV panels are one of the oldest, most reliable and most efficient ways to generate electricity from solar energy, and each PV module is fabricated from a single silicon crystal. That's why it is called monocrystalline, because it is made up of or fabricated from single silicon crystal. And the silicon is why silicon material is used? Because silicon is a semiconductor. We need PN junction, right? That's why it is used. And this silicon is purified, melted and then crystallized into ingots, which are then cut into thin wafers to produce individual cells, right? So before producing the cells, it will be purified first, then melted and then crystallized. Okay, and the typical color of monocrystalline PV module is black or iridescent blue. You might be observed, or you might have observed the blue color. So it is iridescent blue. It can even be in black color, right? And the manufacturing process requires to produce monocrystalline silicon or required to produce monocrystalline silicon is complicated, and it resulting in slightly higher cost than other technologies. Since it is very complicated, this results into higher costs of this monocrystalline type, and the efficiency is high in the range of 15 to 24%, as they are fabricated from the highest grade silicon, making them cost effective in the long term, right? Even though costs are less, but in the long term they are cost effective because their efficiency is more, right? See, the 15 to 24% efficiency itself is considered as more efficiency. Okay, so the maximum value possible is 100%, but if you observe here, 15 to 24% itself is considered as high efficiency in case of solar panels. Note this. And monocrystalline solar panels are generally utilized for large scale solar applications such as commercial and residential solar installations. Okay, what about polycrystalline silicon PV panels? These polycrystalline silicon PV panels uses solar cells that are made from multifaceted silicon crystals, whereas in case of single it is only one. Here it is multi, right? That's why it is called poly. Poly indicates multi, single indicates, what is that? Mono. Okay. Now the appearance of polycrystalline cells is not as uniform as the monocrystalline solar cells, and they have a surface with a random pattern of crystal borders rather than the solid color of single crystal cells. And since a low cost silicon is used to fabricate polycrystalline cells, their efficiency is less, right? Because it is made up of low cost silicon and a value slightly less than the monocrystalline cells, right? Because we have seen the efficiency of monocrystalline cells is up to 24%. Here it is only up to 14%, but much higher than solar technologies such as thin film. So if you further see or go for thin film solar cells, it might be further less. That's why these polycrystalline silicon PV cells are having more efficiency than thin films, that we will see. Okay, the production process is simple. cost effective and reduces silicon waste compared to single crystal panels, right? And polycrystalline solar panels are the most used PV panels on the earth. Since they are less costly, even though efficiency is less, we generally go for less costly things. And they are offered in a wide range of power ratings, even from less power of 5 watts to 250 watts or more, for use in both residential as well as commercial installations. Okay, now let us see thin film or amorphous silicon PV panels. And these cells are made up of depositing silicon in a thin homogeneous layer onto a substrate rather than creating a rigid crystal structure. There is no concept of crystal involved here. That's why they are not of crystal type. They are amorphous or thin film types. Okay. Now, if you see, these absorb light more effectively than crystalline silicon. The cells can be thinner, and amorphous silicon can be deposited on a wide range of substrates, both rigid and flexible, which makes it ideal for curved surfaces or bonding directly onto roofing materials. Okay, there is some flexibility with respect to amorphous silicon, and this technology is, however, less efficient than crystalline silicon, with typical efficiencies of just around 6%. Okay, and it tends to be easier and cheaper to produce, right? So if you observe, efficiency range of mono crystalline is 24%, and the range of poly is 14%, whereas the range of thin film or amorphous is 6%. But it is varying, it is continuously varying. The values may be different in different research papers. As time varying, the research is being done in increasing the efficiency of solar cells. So that's how the efficiency will also be varying. Let us see. Okay, and you know, the amorphous can be thin film, or thin film is also a separate one. We can even consider thin film as a separate structure. So if you specifically deal with the thin film, these cells are made up of depositing one or more thin film layers or thin films of photovoltaic material on a substrate such as glass, plastic or metal. Okay, so in contrast to silicon solar cells, thin film solar cells use direct band gap materials, which allows for thinner absorbing layers, and this thickness varies from a few nanometers to tens of micrometers, much thinner than crystalline silicon. And this thinness allows thin film solar cells to be flexible and lower in light weight. And when compared to silicon modules, these thin film solar cells are durable, simpler, lighter and easier to develop. And energy conversion efficiency of thin film solar cells is much lower than the crystalline silicon PV cells, as just now told. So there are different types like rigid cadmium tellurine panels mounted on supporting structure, which are shown on left, and copper indium gallium selenide is there, which is there in the middle, and flexible amorphous silicon cells are being installed onto a rooftop are shown in the right. Okay, and these copper indium gallium selenide, that is CIGS, is one of the three mainstream thin film PV technologies, the other two being cadmium telluride and amorphous silicon. Okay, the attraction of these technologies is that they can be manufactured by relatively inexpensive industrial processes. Okay, they are inexpensive, and the efficiency of thin film solar cells are generally less than conventional solar cells. And despite the competition from conventional silicon solar cells, the thin film technologies hold many unique promises, allowing solar cells to be produced with much lower energy payback times and with much lower material consumption. And one disadvantage is the use of highly toxic materials here, such as cadmium and gallium arsenide. So these are the different polymer solar cells which are shown here. You can observe, and the different efficiencies ranges are also given. You can just go through this. Okay, they are gradually reducing from monocrystalline to polycrystalline. Just observe this, that's it. Thank you.